Greenland's thinning ice. Presented by Science at NASA. With temperatures around the world climbing, meltwaters from the continental ice sheets of Greenland and Antarctica are raising sea levels. Those ice sheets are melting from both above and below. Much of the ice lost from the ice sheets comes from a process called calving, where ice erodes, breaks off, and flows rapidly into the ocean. A large volume of ice is also lost from ice sheets melting on their surfaces. To determine to what extent Greenland's glaciers are being melted from underneath, NASA recently began a 5-year airborne and ship-based mission called Oceans Melting Greenland, or OMG. Previous research has shown that Greenland's glaciers, which flow like rivers of ice into the ocean, sit on the ground deeper below sea level than had been thought. Warm ocean currents sweep across and erode the hidden glacier faces. As a result, they're melting faster, a few feet a day in summer, than anyone suspected. Oceanographer Josh Willis is the principal investigator for the OMG mission. He says, "We're investigating how the ice interacts with the ocean and how much the oceans are melting away the glaciers from the edges of the ice sheet." For this study, a NASA aircraft is flying the Glacier and Ice Surface Topography Interferometer, or GLISTEN instrument, around Greenland for a few weeks each year. Willis says GLISTEN is making very high-resolution maps of the ice, showing us how fast the glaciers are thinning and retreating right at the edge. The aircraft will also continue dropping more than 200 ocean probes each year through 2020 to measure how temperature and salinity change between the ocean surface and the seafloor, from the cold meltwater at the surface down to the warmer, heavier salt water below. This will help determine how changes in the ocean affect the ice. In addition, OMG has completed surveys using a ship equipped with sonar to measure the seafloor shape and depth, which affect where and how much the warm water from the Atlantic eats away at the coastal glaciers. The mission also conducted airborne measurements of gravity off the coast of Greenland, giving the team more information about the depth of water in those locations. While OMG is looking at the effects on ice sheets from below, NASA's Operation Icebridge mission is surveying polar ice from above. The overlap of OMG and Icebridge is providing the most accurate measurements to date of changes in Greenland's ice sheet mass. Glaciologist Alec Zendar, a member of the OMG science team, says Icebridge's highly accurate airborne topographic mapper is the gold standard of measuring the surface elevation changes of the ice sheet. With OMG uncovering how much ice is being lost at the periphery of the ice sheet, and Icebridge telling us how the thickness of the glaciers is changing further upstream, we can better attribute Greenland's ice loss either to changes in the ocean or warming of the atmosphere, which directly melts the ice from above. Greenland contains enough ice to raise global sea levels by 20 feet or 6 meters if it all melted, notes Willis. Right now, we think this will take at least several hundred years, but data from OMG are helping scientists better understand how much the oceans are melting Greenland's ice. From now through 2020, OMG will be making annual visits to measure the oceans and ice together, helping scientists study changes to Greenland's ice sheet and how those changes may impact Earth's environment. For more science news about our ever-changing home planet, stay tuned to science.nasa.gov.